All right, good afternoon. So my name is Mika Hatanpää. I'm from Nokia, heading the R&D for the Nokia data center development activities based in Espoo, Finland. And what I will be talking about here is the openEDGE solution and talking something about the openEDGE deployments as well. So overall, if you think of the edge, so in the edge, the data center facilities are often very limited in terms of space, power, and cooling. And due to the limitations, it's not possible to deploy the traditional data center gear in these facilities that are typically often existing or old radio sites, for example, for the telco operators. So they are very, very small sites and not at all data center-like in many cases. So in this presentation today, what I will be talking about is the solution for this edge data centers, what we have actually contributed to the Open Compute project. So I will be talking about the openEDGE server specifications and design requirements, then also about requirements for a kind of openEDGE rack solution for the indoor deployments, and then also I'll be talking a few words about the openEDGE deployment scenarios or use cases, what we see. Few words about this contribution that we have done. So at Nokia, the name of the product is Airframe openEDGE server. It is contributed to Open Compute project as part of the openEDGE project that has been established. And the good thing actually is that this contribution was accepted by OCP for the chassis design this week. And now there's a link also to the marketplace because of that. And then a few words about this edge. So what do we mean with edge when we talk about the edge deployments? For Nokia, that means very much the kind of edge of the network or edge of the mobile network or edge of the fixed network where we then deploy the gear. Overall, we kind of define the architecture for this virtualized kind of network functions virtualization for the telcos, so that there are central data centers and regional data centers, aggregated edge, and the so-called far edge of data centers. And typically, the kind of virtualization of this telecom network workloads has kind of started from the central data centers and regional data centers, where you typically see the kind of core network functions virtualized, but then clearly, as of today, the virtualization trend is also now moving towards the edge, which means then that we are then virtualizing functions like baseband processing and let's say ONU could be one example, and so on. But really the kind of edge equipment is getting virtualized as well. And for that purpose, we are then developing the platform that can then support and that has enough computing power to be the kind of virtualization platform for the applications running in the edge, which are quite often kind of user plane type of application, not so much like control plane signaling driven applications, what we would see in the central data centers. Overall, if you think of the challenges when moving towards the edge, is that it is more cost efficient to build large data centers and run those large data centers. But the problem is that then those are far away from the traffic and cannot really handle all of the use cases that we need to support there. So in order to guarantee the low latency and efficient transport, we need to deploy the gear closer to the edge of the network and then build what we call edge data centers there, which are, as said, typically existing telco sites with fairly different kinds of capabilities than the traditional or let's say typical data centers would be. In these radio sites, there's typically no space for traditional data center hardware, but then on the other hand, if you would go to this classical data center or use the classical data center hardware, that's not designed for edge either. But so what we kind of target to do is really so that the content stays close to the end user, that then enables the low latency for the services that we are providing from there. And at the same time, when the content stays close to the user, then it actually doesn't need to cross the network and go all the way to the core network and typically back from there. And that is then also saving resources in the backhaul or in the transport of the network, and then of course cost in building the networks as well. So one additional thing about this solution is that because as I said, so we often deploy into existing radio sites, and we are even virtualizing the radio functions what we have today running on a special purpose hardware. That then means that our target has been that we are actually designing the hardware so that it fits to the same form factor as the typical existing baseband units, for example, for the radio processing, are fitting into and can utilize the same site solutions and enclosures and racks, for example, that might be existing on the locations. In this picture, for example, there are the kind of outdoor enclosures that we also have in the display in the booth here. That would be one example of a deployment, and really it's a fairly small box that you need to fit into, and you cannot fit a very large open rack into this enclosure or even a rack mount server. Then I'll be talking about the openEDGE server design. So this is what we have contributed. The specifications are actually found in the Open Compute wiki pages under the Telco project, and there under this openEDGE project. But I just briefly want to highlight some things about the design that has been contributed. So overall, looks like that. So it's a 3U chassis. It's a 19-inch mountable device going into the standard EIA 310 compatible rack solutions. The important part of this whole design is the depth of the solution. So the depth is this 430 millimeters, and that is really the hard requirement from several telco deployments that you need to fit into a rack that is maximum 600 millimeters deep. And in order to fit there, plus have all the cabling and everything in the rack, so then this about 430 millimeters has been the kind of target design for us, or for this hardware solution. We can support 1U and 2U half-wide sleds in this design. It has the redundant and centralized power supplies, and the maximum power for this enclosure or this chassis is 200 watts in total. And then there's a need typically also then to support different types of power feed options, so different AC feeds as well as the minus 48 volt DC, which is still very much used in telco sites. The sled power feed capacity is 400 watts for the 1U sleds and 700 watts for the 2U sleds there. I will not go to the details, but there's a kind of block diagram of this overall architecture with the PSUs, the power distribution boards, backplanes, and the sleds, and the so-called RMC or rack management controller or chassis controller here. Few other words. So cooling, the fan units are part of the sleds. The reason for that is that in some cases we don't have rear access at all to maintain the system, which then means that we need to get the fans out as part of the sleds to be able to service them if needed. Then there's a rack management controller or chassis management controller. We call it RMC because in other designs it's RMC as well. Maybe it should be called CMC here. But anyway, it controls the PSUs, sensors related to the PSUs, and then also the presence of the nodes in the system, for example. Then there's also the management Ethernet interface in the RMC. So basically, idea is that we can manage all the sleds in this chassis by connecting only to this RMC that has then a small switch that then actually routes all the traffic to the different nodes through the backplane. And in every one of these sleds or compute sleds in this design, there's a separate kind of normal BMC actually that then manages the node itself. So Then about the sled design, so 1U sled is described here. So design is 1U, half wide, fitting into this enclosure, max 400 watts power per sled. So it's a single socket CPU design using the Intel Xeon Scalable processor family at the moment, Skylake, soon Cascade Lake. The max power consumption or TDP for the CPU on the sled is 205 watts. There's two different PCH options. The other one is with this quick assist technology that can be then utilized for encryption purposes, for example. In total, there's 8 DIMM slots. Typically, we would use 6 for the DIMMs in order to have the balanced DIMM configuration, plus then the additional could be utilized for Intel Optane memory if that is needed or wanted to be used. There's a single riser that is then connecting the add-in cards as well as the hard disk backplane there to the front. Extension slots, there's one PCIe by 16, full height, half length, 70 watt slot plus OCP Mezzanine 2 slot as well. And then storage, 2 hot pluggable SSD or HDD slots, and then 2 M.2 SSD slots as well. 2U sled is fairly similar. It's of course higher, and the max power consumption is 700 watts. The CPU is the same here, so it's this Intel Skylake SP processor, but the TDP max is 250 watts for this one. PCH options are the same, and the memory as well. The extension slots there's of course more here. The big difference is that we can utilize full height, full length, dual wide cards even in this one, for example, for the large GPUs like in the picture is shown. Then storage, there's more storage in this design, in these 2U sleds, of course, because there's more space for that. So this has been contributed, and as said, so the contribution was accepted for the chassis design. The sled design at the moment is targeting for the inspired status. There's a links to the specifications and other material that is available in the Open Compute wiki pages. About the rack configuration, so briefly about some use cases that we kind of now initially target with this one. There's a lot more to come, but the typical use case that is very much driving the development of this, or has been driving the development of this openEDGE chassis and the design is the Cloud Run deployments, especially so-called vRAN architecture, where we would typically utilize 1U servers that are then equipped with accelerators. So basically, we would be using PCIe cards that can then accelerate the radio layer 1 baseband processing functions, and then rest of the radio stack, so layer 2, layer 3 would be then processed on the CPU itself. Then the chassis itself actually is designed so that the slots are equal. So basically all the slots are the same. They get the power and they get the management connectivity, and that has then the advantage that basically you can also fit any kind of sleds into the slots. And for example, what we are using there is accelerator sleds to process the front-haul connectivity for the radio networks. So, and actually, it has been one of the design principles that we did not want to put a lot of or a kind of a special purpose backplane into the design as such, because we really wanted to be able to use the slots equally for any kinds of different designs that we might want to use there. That then means, of course, that the connectivity itself between the sleds would have to be done using cables. But again, that gives you the possibility for or gives the flexibility for utilizing all kinds of cabling options or for the connectivity. Then the other use cases, some mobile edge use cases that then require the GPU cards. That is then typically, of course, then utilizing this large 2U sled with the full height, full length accelerator cards, GPU cards, and then for the storage part, we can then support the NVMEs on the U.2 base. Then something about the rack configuration. So the design itself is targeted to be utilized in several different kinds of locations. And I'd say the typical location in most of the cases would be an indoor location. And so utilizing a standard 19-inch rack there. But then we also do support the outdoor enclosures and outdoor deployments using the outdoor cabinet for the design itself. So a few words about the rack requirements. This is something that we have been kind of looking for, and so it's coming there. But we just wanted to share that also for the community, because we do see that there's a need for the rack solutions also for the openEDGE. There's a rack solution for OpenRack, for example, but not an open solution available for the openEDGE project itself. We do see that it should be a standard 19-inch EIA-compatible rack. Typical depth would be 600 millimeters. It can be less than that even, but I think for this 600 millimeters should be the target for the design itself. The airflow options need to be taken into account when thinking of the doors, for example, that there needs to be front to rear and rear to front capabilities. And then various power feed options need to fit into the racks, meaning basically the different kinds of PDUs to support -48 volt or the different DC options for the design itself. Operating conditions, well, for the system itself, that is then according to the NEPS specifications. So typical would be the operating temperature from -5 to +45 C, and then for the short term up to 55 C, as defined in the NEPS GR63 core specification. Humidity 5 to 95. And the seismic tolerance is an important feature for the rack itself. So really that rack has to be stiff enough to hold the equipment or the equipment that is then put into the rack up to the NEPS zone 4, NEPS 3 zone 4 specification. And that is a very challenging requirement because the weight of the equipment in the rack could be up to 500 kilograms, for example, and when you shake it with that load, it has to be very stiff. So then there are other solutions for extreme environments, but this would be the typical for the indoor deployments. Other things to be taken into account are related to serviceability. So they might not be, or it has to be front access for easy full front access, actually for easy serviceability and front cabling. There has to be enough space for large number of cables coming from the systems, and then rear access might not be in some cases available at all, which means that okay, if you have a door, you might not be able to open the door actually from the rear side if the equipment or if the rack is installed next to the wall or next to the other cabinet. Toolless serviceability is the target, and door opening direction shall be reversible. But this is just few very high-level requirements that we have been defining for the rack itself. We can share more for sure. Then something about the openEDGE deployment use cases. So as said, so typical installations would be using a 19-inch rack for the indoor environments. The left-hand picture is about that. Then the middle picture is actually from one use case where there is an existing radio equipment rack that actually does not have the rear access at all. So basically the mesh that you can see in the backside there in the picture, that is something that is welded into the rack, so you cannot open it at all. And in order to fit there and in order to be able to maintain the openEDGE system there, as said, so everything has to be fully front serviceable. Then the other picture there is actually the same that we are showing in the booth there, which is an outdoor cabinet with the kind of heat exchanger, so that the openEDGE chassis is fitted into the enclosure and can be then pole mounted or put to the roof of a building or wherever. Similarly here, just some other pictures of this. So it could be in the rooftop, for example, using the outdoor enclosure, or it could be on the street side using a street side cabinet as well. So these kind of locations exist today for example, for baseband processing, and really target is that this openEDGE server has to fit into similar locations. So in summary, briefly, so as said, so new use cases are driving. So especially in our case, the virtualization of the telecom networks functions overall. But there's a lot of other edge use cases for sure. But they are driving the computing capacity from, let's say, classical centralized data centers towards the edge of the network. But then the requirements of the edge data center deployments are definitely different from traditional data center or large-scale data center facilities, and that is then leading to a different type of design that has been now contributed to the Open Compute project. And so briefly, just to summarize what I was sharing is that the edge data center, what are the edge data center deployment scenarios? For sure, there's more. That's just a few examples here. Then, as said, so there are now the openEDGE server specifications and design files available in Open Compute wiki pages, and requirements for the openEDGE rack solution were briefly described, and we would definitely like to see that such rack designs are also getting incorporated under the openEDGE project. And then examples of the configurations and deployments were briefly discussed. Call for action is here. So there's an openEDGE sub-project that has been established under the OCP Telco project. Mike Moore is leading that one. Mike is there. And I just copied some text from the charter of this project there, but of course the project itself is public and everybody is welcome to join that and contribute to the project. So I think that's all from my side. Has any questions today?
I have a question about these things. You know, you mentioned about some remote site, the space may not be enough. So, but what I have seen is you only have the modular design instead of like a rack mount with just small size server. So it's like you have a big chassis with modular servers. So that is bigger than like a 1RU small server rack mount. So
yeah, I think that the typical challenge is the depth of the equipment itself, and really the depth of a rack mount is typically 80 centimeters, and you need at least 1 meter deep rack that doesn't fit into the kind of locations where we are targeting to in the edge, and so in that sense you have to be much shorter in terms of depth. The height itself is not a big issue as such if you have a rack anyways where you are putting the equipment into, but the depth itself is really what we need to minimize.
So in the 1 and 2U servers, I saw some 2.5-inch slots, and you mentioned HDDs. Most of the enterprise-grade HDDs are 3.5-inch. So do you not expect HDDs to be used here at all, or?
We do support HDDs, especially with the 2Us, so it's easier to fit there. But typical deployments as what we are using, so we are actually fully SSD deployments.
So typical deployments is all SSDs?
Yes, yeah.
deployment or trial
Yes.
for this openEDGE?
Can you say again?
Is there any commercial deployment or trials?
Yeah, there's some, a couple of commercial deployments are now starting. There's a large number of trials and POCs at the moment ongoing. The product is new, so basically the product was launched, we launched it last year already, but the kind of GA was end of last year, so it's now just ramping up at the moment. But for sure, there's a huge number of interest and quite a few trials and POCs at the moment. Okay, if nothing else, so maybe we can close.